I also like this problem a lot because it is a great example of a very important problem-solving technique. This problem is number 25 from the 2000 AMC 8. And the important problem-solving technique is to use an example. If you read through this question, it's a very generalized rectangle. It really doesn't give you any idea about the rectangle instead of the area being 72. And what that means is the area doesn't actually matter. Or not the area does matter, the dimensions don't actually matter for this problem. So we can actually make up our own dimensions. So if you know the area are two things that multiply together to give you 72, you can find this answer. So the easiest are 6 and 12, and so if we let AD be 6 and DC be 12, that satisfies that first condition. And then it says point A, and then the midpoints of BC and CD are joined to form a triangle, then what is the area of that triangle? Well, I can find that because if these are midpoints, then this is 6, this is 6, this is 3, this is 3. We already know this up here is 12. Well, a great way to find the area of a shape that's inside a shape is to find the area of the whole thing, which would be 72, we already know, minus each of the parts. And so this triangle here is 1/2 times 6 times 6. And then this triangle here is 1/2 times 3 times 6. And then that other triangle, this one right here, is just 1/2 times 12 times 3. If you go through and calculate what's inside here, you get 18 plus 9 plus 18, which turns out to be 45. So the answer to this question is 27. So by finding a nice example that fit the conditions, we're able to easily solve this problem. Now, you could have done this another way, in that you could have gone through and used, called this x, and this y, and this y, and then this would be x over 2, and this would be x over 2, and this would be 2y. And so we would know that 2xy is equal to 72. That's what the condition of the area is. And then we could say that the area that we want is going to be 72 minus, well, it's going to be 1/2 x times y, right? That's what this triangle is. Minus, now this triangle is going to be 1/2 y times x over 2, which turns out to be 1/4 xy. And then this triangle over here, and since it's x over 2 times 2y, the 2 and the x over 2 cancel out, and so it's the same as the first one, minus x over y. And then you can see that from what I did here, if you divide both sides by 2, xy equals 36. So I just plug 36 into all of these, and I end up with the same thing that I did before. And so that's a more algebraic way to solve it, but I really like the problem-solving technique on the first one, which comes up a lot. If you're given a condition that is can be met in a lot of different ways, a lot of times using an example for that condition is a great way to move forward.